All right, in this video, we're going to be talking about coterminal angles, reference angles, and special right triangles. So let's start with coterminal angles. What is a coterminal angle? So let's say we have let's say this is a 30-degree angle here. And remember that for an angle in standard position, the vertex is at the origin. The initial side is along the positive x-axis, and then the terminal side is just wherever the other side lands. If we had another angle, let's say we have a negative angle going clockwise, and we rotate past 90, past 180, past negative 270, and we end up with the same terminal side, point in the same direction. So that would be, let's see, 270, and this would be 60 here. So that would be negative 330. So that negative 330 degree angle has the same terminal side as 30 degrees. So those two angles are coterminal. All right, have the same terminal side. If we were to look at, let's say, a third angle, and let's say we're going to go back to being a positive angle, going counterclockwise, and let's say we go past 30 degrees, past 180, we do a full rotation and then come back around and then stop again at this same terminal side. And that would be full rotation 360, add that 30 degrees, and that would be the angle 390 degrees. Then that's also a coterminal angle because it has the same terminal side. Okay, so coterminal angles are angles with the same terminal side. I guess we should say same terminal side. All right, and we're assuming standard position. Assume standard position when we talk about coterminal angles. All right, so let's look at some examples of coterminal angles. You'll be asked to find both a positive and a negative coterminal angle for a given angle a lot, and know that there are an infinite number of coterminal angles because we can go an infinite number of rotations and land on the same terminal side. So when you're asked for one positive, one negative, just know that there's not a unique answer to that. So if we're given this one, like in example number one, we've got 100 degrees here. If we want to find our coterminal positive angle, then again, we can go to 100, going clockwise, and then go another full rotation and end up with the same terminal side. So again, to get that value, to get that angle measure, we went 100, and then we added a full rotation. So 460 degrees counts for our positive coterminal angle. All right, if we wanted to go negative, then we could go we could go clockwise. Again, from that initial side in standard position, and end up at the same point in the same direction. Okay, to find out what that value is, we could take our original angle 100 and think about it like we are doing a full rotation clockwise from that 100 degree angle. Okay, so we're taking away a full rotation. Okay, so 100 take away 360 degrees. It's going to be negative 260 degrees. Again, we went clockwise, so that's a negative. So that negative 260 degrees, it's negative, counts for our negative coterminal angle. Again, you could keep adding or subtracting any multiple of full rotations of 360 degrees, or 2 pi's if you're in radians, to get other coterminal angles. All right, in your notes, if you would, try these next 3 examples, example 2, 3, and 4 in your notes. We'll talk about them together in our next class. Okay, next up, reference angles. All right, so a reference angle is the acute angle. Oh, that's not what I want. And again, acute angles are between 0, 90 degrees. The acute angle formed by the terminal side and the x-axis. All right, so what does that actually look at? Let's say we have a 200 degree angle given to us, okay, and we want to find the reference angle for a 200 degree angle. Okay, so first off, 200 degrees is bigger than 180, so we're going to end up, but less than 270, we're going to end up in that third quadrant. So if we go 90, 180, and then a little bit past that, okay, that's our 200 degree angle there. Okay, that's our given angle. If we want to find our reference angle, then again, according to our definition, we're looking for the acute angle formed by the terminal side. Here's our terminal side and the x-axis. All right, so we're looking for this angle in here. All right, the measure of that angle. We're going to just name that angle angle alpha so that we know that alpha and theta are different angles. And so that angle, we went 180 and then an extra 20 degrees to get to 200 degrees. So that reference angle there is 20 degrees. That would be our reference angle. All right, and we just want to find the measure of that angle. Okay, another example, example 5. We're given the angle negative 13 pi over 9. And again, we want to find the reference angle. So we're looking for the angle formed by the terminal side and the x-axis. So we're looking to find the measure of this angle here. So we're in radians on this one, and we're negative. The direction isn't a big deal, but when we're dealing with radians, we just have to kind of change our mindset to deal with pi's and deal with fractions a little bit more. What I really want to find is this angle in here, this alpha. And so if I take away this 180 degrees, or this pi, then I want to think about what is 13 pi over 9. Take away pi. So take away this kind of about face, this 180 degree turn here. So since I'm subtracting, one of them's a fraction, I want to get these with common denominators. So pi is the same thing as 9 pi over 9. So 13 pi over 9, take away 9 pi over 9, leaves us with 4 pi over 9. And 4 pi over 9 is going to be this alpha here. That's going to be our reference angle. Okay, it's acute angle. It's less than pi over 2. And that's what we're looking for. All right, there's 2 more examples, example 6 and example 7. Leave for you to do in your notes. Okay, sketch those angles. Draw the little direction arrows that come with them and find the reference angles that go with each of those. All right, our third and last topic is special right triangles. So special right triangles is a topic you've seen in previous classes. So I just want to take a minute and review this because we're going to use all 3 of these topics to create study and use the unit circle, which is going to be a big tool for this unit and for the rest of the semester. So the two special right triangles are our 45-45-90 triangle and our 30-60-90 triangle. They're named such for their angle measures. So let's focus on the 45-45-90 triangle first. So because we've got two congruent angles, or two 45s here, then that means it's an isosceles triangle. So the angles opposite, the sides opposite congruent angles are congruent. So that means both of the legs of this right triangle are going to be the same measure. That's why they're both labeled with an S. And the hypotenuse, because it's a 45-45-90 right triangle, it has a measure of S root 2. If you put these S's into the Pythagorean theorem, you could prove that this is always going to be the case for a 45-45-90 triangle. All right, for a 30-60-90 triangle, you don't have congruent sides because we don't have any congruent angles. We've got three different measures for our angles, 30, 60, and 90. And it turns out that the side opposite the smallest angle, that's always going to be our short leg. The side opposite the 60-degree angle is going to be our long leg. And then the side opposite the right angle is always called the hypotenuse. All right, so the relationship, and that's an L, by the way. The relationship between the sides in a 30-60-90 triangle are if the short leg is some value x, then the hypotenuse is always going to be double that value. Going back to the short leg, the relationship between it and the long leg is always going to be the short leg times root 3. Okay, so we can use these, essentially this as a shortcut to solve right triangles that maybe we don't have enough information to solve them another way. Or they'll be used as a shortcut so that we don't have to use trig to solve certain parts of the triangle. So let's look at a couple of these examples together. So in example 8, it says solve each triangle. And again, solving a triangle just means you find any missing sides or angles. It tells us it's a right triangle. So I'm going to go ahead and put in that right angle symbol in angle C. Because these two sides are congruent, or are the same measure, we know they're congruent. So I'm going to put my tick marks. Because they're congruent, opposite angles from those sides are congruent in a right triangle. If the two acute angles are congruent, they got to be 45s because they have to be complementary. So we got a 45-45-90 triangle. We've got all our angles marked. We need to find this missing side, which is the hypotenuse. Hypotenuse is always x times root 2, or s in this case, since we have a 45-45-90. And our s is the length of each of these sides. So our hypotenuse has a length of 2 times root 2. All right, let's look at example 10. Underneath that one, we've got triangle ABC. Again, we're told in the directions this is a right triangle, so angle C is a right angle. We've got a 30-degree angle up here. So the complement to 30 is 60 degrees. So that's a 60-degree angle for angle B. And we're given the hypotenuse. They want us to come up with the short leg and the long leg. Okay, remember the relationships in 30, 60, 90 right above. We've got our hypotenuse, which according to our diagram here is 2 times that short leg. So we can set that equal to 2x. And then essentially we just want to solve for x and plug it into these two sides. Okay, so if 8 root 3 is 2x, to get that x by itself, I'm going to divide both sides by 2. So that's going to leave us with 4 root 3 is our x value. So that gives us x equals 4 root 3. And again, our hypotenuse is still that length there, 8 root 3. We're just using that to solve for x. So short leg is 4 root 3. We want to multiply that by root 3 to get our long leg. So 4 root 3 times root 3. Any radical times itself is the radicand, that number underneath. So this is going to be 4 times 3. Again, root 3 times root 3 is root 9. Square root of 9 is 3. 4 times 3 is 12. So 12 is our long leg. Okay, so we've solved that triangle. We got all of our side lengths. We got our missing angles. We're good to go. All right, in your notes, if you would do example 11 and example 9. Come into class with those examples done and with any questions if you have them.